Hello everybody, I'm Jacob, the newest member of Kids for Chemistry.
And I'm Miss P. Today, we want to talk to you about aSTEAM Village in STEM City, USA.
aSTEAM Village is a great program that promotes STEM curriculums to children. The mission of aSTEAM Village is to inspire students and families to pursue education and career pathways in science, technology, engineering, arts, and math through community-based project learning and innovative programs.
And every summer, aSTEAM Village conducts a summer camp for kids. This 8-week summer camp for kids, grades 6 to 12, enables learners to explore the world of robotics, video game design, rocketry, race car engineering, alternative energy, and many more science, technology, engineering, arts, and math challenges. The camp includes hands-on activities, bond instruction, competitions, virtual field trips, and interaction with industry professionals. The camp is designed to be educational, explorative, and fun.
I'm happy to announce that the Kids for Chemistry program is being included in the aSTEAM Village Summer Camp.
And as you can see behind me, aSTEAM Village will be providing their own virtual academy in STEM City, USA. STEM City, USA is a virtual city that houses many different organizations. It's where every city should be. It is a community where you find people and organizations that help you become everything you want to be and beyond.
And Kids for Chemistry will be conducting their virtual classrooms here alongside aSTEAM Village. We are so proud to be a part of aSTEAM Village program and look forward to teaching everyone about the first 20 atoms on the periodic table, molecules and ions, acids and bases, oxidation and reduction, organic chemistry, and electrochemistry.
And all of this is taught while playing a game and having fun.
And now, we're going to have Gerald and Awa explain what's included in the Kids for Chemistry virtual class.
Hello everybody, Gerald and I are going to talk about session 1 of the Kids for Chemistry summer camp called Identifying the First 20 Atoms.
And this is where you learn how to identify the first 20 atoms using our patented drawings of the periodic table with the sidebar and the bottom bar.
This is an original drawing developed by Kids for Chemistry and never before used. The sidebar shows how many s orbitals there are for each row and makes it easy for young children to identify an atom and determine which row it belongs in.
The bottom bar shows the electrons in the outermost orbital. S orbitals are the outermost orbital for columns 1 and 2. The atoms in the first column all have 1 electron in the outermost s orbital. The second column has 2 electrons in the outermost s orbital.
P orbitals are the outermost orbitals for columns 3 to 8. Column 3 has 1 electron in the outermost p orbitals. Column 4 has 2 electrons in the outermost p orbitals, and so on. This diagram makes it easy for children to identify the atoms.
For example, this atom has 2 s orbitals, so it must be in the second row. And it has 4 electrons in the outermost p orbitals, so it must be in column 6. Therefore, it must be oxygen.
The Kids for Chemistry drawings provide a powerful visual to help children learn. There is one exception. Helium has an outermost s orbital with 2 electrons, but it is not in the second column, and that is because it is a noble gas.
And now we are going to let Maki and Justin explain session 2 of the summer camp, molecules and ions.
Hello, I'm Maki. Justin and I are going to talk about session 2 of the summer camp.
After learning how to identify atoms, students learn about 7 molecules and ions that are important for the final session in the program, the buzzer experiment. Everything learned in this program leads to understanding the buzzer experiment. Some of the molecules and ions are shown.
There are 6 molecules: water, sodium chloride, sodium hydroxide, hydrogen gas, hydrogen chloride, and chlorine gas. And these molecules can separate to form ions like the hydroxide ion, hydrogen plus, sodium plus, and the chloride ion.
In this session, students learn why atoms want to come together and form molecules. And they also learn about charged particles called ions. Negative charged particles are called anions, and positive charged particles are called cations.
For example, the water molecule is formed because the lonely electrons want to be in pairs.
And speaking of electrons, we are going to let Miss E and Mr. E explain Session 3, acids and bases.
We are here again. I'm Miss E, and this is my man, Mr. E. And you better not say a word. We're going to talk about Session 3 of the summer camp, acids and bases.
To determine if you have an acid or base, you must know if it is donating a proton or accepting a proton.
Most people are familiar with the term acid. They think of a chemical that will burn them if it touches their skin. They are right. Acids are chemicals that are very corrosive, but there are many different acids, and they may vary in strength and chemical composition.
The one thing that all acids have in common is that they all are proton donors. And if something is donating a proton, then something else must be accepting the proton, and that is a base. A base is a proton acceptor, and that is why we group our acids and bases together. Bases are also very corrosive, just like acids.
In this session, students will learn what proton donors and acceptors are. And they will also learn about salts and compare salts to acids and bases.
And now, Orbital and Miss P are going to explain Session 4, oxidation and reduction.
Hello, I am Orbital, and you already met Miss P. Let's summarize the concepts of ions and the concepts of acids and bases before we go on. To put it simply, to determine if you have an ion, you have to compare the number of protons to the number of electrons. To determine if you have an acid or base, you must know if you are donating a proton or accepting a proton. It's all about electrons and protons.
For oxidation and reduction, you have to determine if the molecule is donating an electron or accepting an electron. A simple example of oxidation is when a hydrogen atom loses an electron and becomes a proton. An hydrogen atom has been oxidized. You reverse that direction and a proton accepts an electron to become hydrogen. Then a proton has been reduced. This is called reduction.
And in this session, students will learn about electron donors and acceptors.
We now have Awa and Maki to explain Session 5, the buzzer experiment.
This is the session where we bring everything we learned together to help us understand an experiment called the buzzer experiment.
The buzzer experiment consists of a circuit containing a battery connected to a buzzer by wires. When the end of the wire touch, the buzzer will buzz. This is easy to understand because the battery provides electrons to the buzzer, which causes it to buzz.
But what if we separate the wires, then stick the end of the wires into a container of water? The question is, will the buzzer buzz?
And then what happens if we add ordinary table salt to the water? Again, the question is, will the buzzer buzz?
And the final question is, why does the buzzer buzz?
In order to answer these questions, you must understand the structure of the first 20 atoms, molecules and ions, acids and bases, and oxidation and reduction.
When you understand these concepts, Then you will understand why the buzzer buzzes.
And you will understand the most important concepts that you will need to understand high school and college chemistry.
We now have Gerald and Jacob to explain Kids for Chemistry, the game.
And to top it off, we have a wonderful way to learn the chemistry and have fun while learning. It is called Kids for Chemistry, the game.
This is an interactive board game. The perimeter of the main board contains the first 20 atoms and the 7 molecules and ions. You roll the dice and move to that spot. You must be able to identify the atom, molecule, or ion that you land on. Then you can pick a card with a question on it. If you answer the question correctly, then you win game money.
Whoever wins the most money wins the game. But there's more to the game. You have additional boards where you can learn about identifying atoms, the buzzer experiment, counting carbons, hybridization, organic chemistry, electronegativity, and more.
Our motto is, learn chemistry while playing the game and having fun.
We hope you enjoyed our presentation of aSTEAM Village, STEM City USA, and Kids for Chemistry.
And if you happen to be driving by STEM City, make sure you stop by and visit our virtual learning academy. We would love to have you.